Hello students. In my previous lecture, I had discussed the concept of sampling. Now, I am discussing the methods of sampling. As we know that sampling is a simple process of selecting a sufficient number of elements from the population with the purpose of collecting data about their attributes. Now, it has different methods in order to have the right type of samples with us. The sampling methods are divided into two categories. Number one is probability sampling or random sampling. Number two is non-probability sampling or non-random sampling. Sampling procedure is a typical one. So, random sampling, each unit of the population has the same probability of being selected as a part of the sample. In random sampling, the chance factor comes into play in the process of sample selection. For statistical analysis, a random sample is ideal. However, there may be some cases where random sampling is not feasible. In these cases, non-random sampling method can be a good alternative. As compared to random sampling, in non-random sampling, every unit of the population does not have the same chance of being selected in the sample. In non-random sampling, the members of the sample are not selected by chance. Some other factors like familiarity of the researcher with the subject, convenience, etc. are the basis of selection. On the basis of selection procedure used, random and non-random sampling techniques are referred to as probability or non-probability sampling. This diagram shows that probability or random sampling is further divided into simple random sampling, systematic sampling, stratified sampling, clustered sampling, area sampling, and multi-stage sampling. If we see non-probability sampling, it is further divided into judgment sampling, convenience sampling, quota sampling, panel sampling, and snowball sampling. Now, let us see probability sampling. As I discussed, probability sampling is the sampling in which every unit has same probability of getting selected as a part of the sample. The advantages and disadvantages are as it is more rigorous and free from bias, the absence of systematic error, higher level of reliability, increased accuracy, and possibility to make inferences about the population. The disadvantages are it is complex, more time consuming, and expensive as compared to that of non-probability sampling. Now see, this figure shows that there are different type of probability or random sampling. First is simple random sampling, which is further divided into simple random sampling with replacement and simple random sampling without replacement. Simple random sampling with replacement is the one in which each element of the population has a known or equal probability of getting selected. Or in simple words, we can say that each member of the population has an equal chance of being included in the sample. It is the most common method of selecting a sample from the population. In this method, firstly, a complete list of all the members of the population is prepared. Each element is identified by the listing number. Then the items are selected from the population either by using a random number table or a random number generator, which is a kind of a computer or a software. So if we see the example, point number 2, which says a simple random sample would be the names of 25 employees being chosen from the company of 250 employees. In this case, the population is all the 250 employees, and the sample is random because each employee has an equal chance of being selected. Random sampling is used in science to conduct randomized control tests or blinded experiments. Uh, how we do a simple random sampling is explained by the help of this example. The question is, outline the steps for obtaining a simple random sample for outcomes of strokes in US Trauma Center. The step number 1 is, as I said, make a list of all the trauma hospitals in the US. There may be n number of trauma centers, so we make a list. Second step is assign a sequential number of each trauma center, it could be from 1 to n. This is your sampling frame. Now step number 3 is figure out what your sample size is going to be, how you will find one. And the last step is use a random number generator to select the sample using your sampling frame from step 2 and your sample size from step 3. For example, if the sample size is 50 and the population is 500, generate 50 random numbers between 1 to 500. This is how this type of sampling. It is of two types: simple random sampling with replacement and simple random sampling without replacement. These two are self-explanatory. In first case, each element of the population has equal probability of being selected in the sample, which is equal to 1 upon n, and is your sample size. In second case, each element of the population does not have an equal probability of being selected as a sample. For example, if suppose I have a box in which there are 12 balls of different colors. Now, what is the probability of selecting red ball out of the box? It is 1 upon 12. In case of simple random sampling with replacement, the probability of getting selected for all the balls is 1 upon 12. However, in second case, without replacement, what we do, it does not have an equal probability of being selected. That is, if I take a ball, red ball, it has a probability of getting selected is 1 upon 12. Now I keep it aside. The chance, now I pick up the second ball which is blue in color. Now the chance of getting selected for that blue ball is 1 upon 11. This is how simple random sampling is. The concept of simple random sampling. Now the advantages and disadvantages. This process is simple. It saves cost. It is conducted. It can be concluded in less time. It involves less degree of judgment. The disadvantages are difficult to construct sampling frame. This is one of the most difficult step. The selection of the sample becomes difficult when the population is widely spread. Now, stratified random sampling. It is based on the concept of homogeneity and heterogeneity, meaning we have a heterogeneous population. From that heterogeneous population, we divide that population into small homogeneous groups. This is called the process of stratification. Now, the elements of the population is divided into homogeneous groups. These groups are called strata. Then the researcher used the simple random sampling method to select a sample from each strata. Each group is called stratum. Now, some of the most common strata used in stratified random sampling are on the basis of gender, age, religion, race, education background, socioeconomic status, nationality, etc. In this sampling, stratum should be relatively homogeneous and the strata should contrast with each other. In most cases, researchers use demographic variables, as I discussed, on the basis of age, race, ethnicity, gender. There are two types of stratified sampling. First is proportionate sampling. In this sampling, the size of each stratum is proportionate to the population size. Now it will be clear with the help of this example. Let us say you have four strata with population size of 200, 400, 600 and 800. Now if you have to choose a sample, you need to have a sampling frame which is half of the population. Then in that case you will select random samples which will be 100 in case of 200 population size, 200 in case of 400 population size, 300 in case of 600 population size, 400 in case of 800 population size. This is what proportionate stratified random sampling is. In simple meaning, the sample size should be in some proportion with your population size. The second form of stratified sampling is disproportionate stratified random sampling. In this sample, different strata do not have same sampling fraction. This will be clear with the help of this example. If your 4 strata has 200, 400, 600, 800 population, you may choose to have different sampling fractions for each strata. Perhaps the first strata with 200 population sample fraction is half, so you can have 100 people selected from that sample. While the last stratum is 800, you can have a sampling fraction of 1 by 4, which means that your sample out of 800 is 200. So the fractions are not equal or in proportion with the population size. This is called disproportionate stratified sampling. It again has some advantages and disadvantages. This method is superior to simple random sampling due to lower variability within the subgroups, because as I said, the groups are divided into homogeneous groups, so the chance of error are very less. Homogeneity within the strata and heterogeneity between strata ensure precise estimation. Now the disadvantages are the researcher must be very much clear with the information or the knowledge about the population. It may take longer and can be proved to be more expensive. Now this is systematic or quasi-random sampling. In this sampling method, the elements are chosen from a target population by selecting a random starting point and selecting other members after a fixed sampling interval. That is, the samples are selected from the population at uniform intervals in terms of time, order, or space. The sampling interval is calculated by dividing the entire population, which is capital N, by the desired sample size, which is small n. This is known as sampling fraction. Systematic sampling is an extended implementation of simple random probability sampling technique in which each element of the population is selected at regular interval to form a sample. Mark my words, it has a regular interval or a uniform intervals. There is an equal opportunity for every element of the population to be selected using this sampling technique. This is suitable for various researches where there are budget restrictions, where uncomplicated implementation due to defined sampling interval to decide the sample, or it can be used in the absence of pattern in data, or it can be suitable in collecting data from geographical dispersed cases. Now, choosing a sample size through a systematic approach can be done quickly in this. Once a fixed starting point has been identified, a constant interval is selected to facilitate participant selection. Now, for obtaining sample in this sampling, first of all, the sampling fraction is decided, which is denoted by a small k, which is actually in mathematical form is equal to capital N divided by small n, which is elements in the population divided by the sample size. This is called your sampling. Now will be clear with the help of this example. A researcher wants to take a sample size of 30 from the population of size 900 and he decided to use systematic sampling. The step 1 would be to calculate sampling fraction, which is number of elements in the population divided by sample size. So 900 divided by 30 is equal to 30. Now the first member can be selected randomly and then after every 30 member the member can be selected. So the regular interval is 30. So you need to have 30 members in between to select another member. This is what systematic is. The advantage is it is precision in sample selection. In case of diverse population, this method is widely used and very helpful because of even distribution of members to form a sample. It is simple and convenient also. The major disadvantage of this systematic sampling is it can be applied only if a complete list of population is available. That is, we cannot use this type of sampling when the researcher is not having a clear information of the population. Now this is cluster sampling. In cluster sampling, we divide the population into non-overlapping areas or clusters. It might be seen as there is no difference between stratified sampling or cluster sampling, but this is not true. In fact, there is a well-defined difference between stratified sampling and cluster sampling. As I said, in stratified sampling, strata happens to be homogeneous, but in cluster sampling, these clusters are internally heterogeneous. A cluster contains a wide range of elements that are good representative of the population. The population is divided into overlapping areas or clusters. As I said, it is used when a researcher can't get information about the population as a whole, but they can get information about the cluster. This will be clear with this example. In a city, the list of all the individual persons staying in the house may be difficult to obtain or even may be not available also, but a list of all the houses in the city may be available. So every individual person will be treated as a sampling unit while every house is treated as a cluster. Now let us see the advantages and disadvantages of this. Most efficient and economical for large geographical areas. It is easy to implement and larger sample size can be used due to an increased level of accessibility. The disadvantage of this is it requires group level information. Generally, it has higher sampling errors. So, this there are three stages of cluster sampling. It is again explained with the help of this example. A researcher wishes to know the number of residents using Delhi Metro. Okay, since Delhi NCR is a very large area, the decision regarding sampling frame, sampling technique, and sample size needs to be taken into consideration. Now, the first step in this or the first stage of cluster sampling is select the cluster grouping as a sampling frame. In the above example, we can group on the basis of north, south, east, west, etc., which can represent the sampling frame. Stage 2 is mark each cluster with a unique number. It could be any number which can be easily given. Third is choose a sample of cluster, apply probability sampling. Now, choosing systematic random sampling, we can choose region from the total regions. Resident traveling from that region will represent the sample of that region. That is, if we see north, this is one of the cluster. By using any type of random sampling, we select any individual who is traveling from the north region to other region. It could be the sample from that particular region or a cluster. Now this is the difference between cluster sampling and stratified sampling. On the basis of definition, Cluster sampling is the members of these sample are chosen from naturally divided groups called cluster by randomly selecting elements to be part of the sample. In this stratified sampling, members of this sample are randomly chosen from overlapping or homogeneous strata. Purpose: the cost reduction and increased efficiency. In stratified sampling, it is enhanced precision and population depiction. Sample selection in cluster sampling is done by a randomly selected cluster and including all the members of this cluster. In stratified sampling, it is done by randomly selecting members from various formed strata. Division, it is naturally formed, it depends, and in stratified sampling, depends upon the researcher. Heterogeneity, it is very important point. Internally, the cluster are heterogeneous. On the other hand, in stratified sampling, externally between various strata there is a heterogeneity. Externally between various clusters there is homogeneity. On the other hand, internally with the strata there is homogeneity. So these 2 points are very important in case of cluster sampling and stratified sampling. Now coming on to multi-stage sampling, this is yet an important form of sampling technique. It could be taken as multi-stage cluster sampling because it is more complex and contain 2 or more stages in sample selection. The population consists of primary stage unit and each of these primary stage unit consists of secondary stage unit. Difficult, huh? Let me explain. In the process of multi-stage sampling, first a sample is taken from the primary stage unit and then a sample is taken from the secondary stage unit. For example, the researcher wants to select 200 urban households from the entire country. Okay, I repeat, a researcher wants to select 200 urban households from the entire country and want to use multi-stage sampling. For this purpose, he may first select 27 states from the country as a primary sampling unit. Then, during the second stage, he may decide 50 districts from these 27 states may be selected. Finally, 4 households from each district may be randomly selected. Thus, a researcher will obtain the required 200 urban households in 2 stages. Another example, if I want to do a sampling for study the diversity in hospitals, the 2-stage multi-stage sampling is used. The first stage maybe the hospitals should be multi-speciality hospitals and the second stage would be that it should have a bed strength of 250. So this is another example of multi-stage sampling. In simple terms, in multi-stage sampling, large clusters of population are divided into small clusters in several stages. It has to be acknowledged that multi-stage sampling is not as effective as true random sampling. However, it addresses certain disadvantages associated with true random sampling, such as being overly expensive and time. Let us illustrate this in an example. I had already discussed this example. Now with this diagram, the example could be much more clear. I want to select 200 household. Now from the state, I select 27. I select 27 states, and from each state I select certain number of district, and from district I select certain number of villages, and from that villages I select my desired households. So this is called multi-stage sampling or multi-layered sampling. In this example particular picture, we have 4 stages of selecting the sample. The advantages of multi-stage sampling is it is effective in primary data collection from geographical dispersed population. It is cost effective and time effective and highly flexible. Disadvantages: it is It has high level of subjectivity. Researcher findings can never be 100% representative of the population. The presence of group level information is required. This is called multi-stage. Now this is non-probability sampling. It is a sampling technique where the selection of the sampling unit is not based on a random selection process, and hence this is called non-random sampling technique. In the selection of the sample units, the probability is not used, where or which is why these techniques are also termed as non-probability sampling techniques. There are various different types of non-random sampling like quota, convenience, judgment sampling, which I will be discussing in later slides. So, a non-probability sampling is a sampling where the odds of any member being selected for a sample cannot be calculated. It is the opposite of probability sampling, where you can calculate the odds. In addition, probability sampling involves random selection, while non-probability sampling does not. It relies on the subjective sampling of the researcher. This will be clear with the help of this example. Suppose one person could have 10% chances of being selected and another person could have 50% chances of being selected. That is, the selection of any person does not have equal chance. One might have 10% chances of getting selected and other might have 60 or 50% chances of getting selected. It has various advantages and disadvantages as well. The advantages are possibility to reflect the descriptive comments about the sample, cost effectiveness and time effectiveness compared to probability sampling, effective when it is unfeasible or impractical to conduct probability sampling. So all the disadvantages are covered in, or rather I should say all the disadvantages of probability sampling are covered by the help of this non-probability sampling. Coming on to disadvantages, first is unknown proportion of entire population is not included in the sample group. That is lack of representation of the entire population. This is the one major drawback of this sampling. Lower level of generalization of research findings compared to probability sampling. And the last is it is difficult in estimating sampling variability. Now, coming on to different types of probability sampling, the first one is judgmental sampling. It is. In judgment sampling, the selection of sampling unit is based on the judgment of the researcher. In some cases, researchers believe that they will be able to select a more representative sample by using their judgment, which will be time and cost efficient and are more accurate than simple random sampling. This sampling technique also suffers from the limitation of other non-random sampling technique like the judgment of the researcher make the sampling process non-random and hence determining sampling error is very difficult because probability are based on non-random selection. In addition to that, judgment sampling does not provide a basis for comparing the judgment of two different persons. There is no well-defined scientific method which can tell us that how one person's judgment is better than other person's judgment. Generally, judgment sampling is useful when a sample is small. In large sample, the biases from the researcher end may be high. Let's see what I have written in this. This is same which I have explained to you. Coming on to convenience sampling, it is yet another very good sampling technique. In this, the sample elements are selected based on the convenience of the researcher. In this case, the researcher includes samples which are readily available to him. The focus is on the convenience of the researcher. For example, a marketing researcher firm wants to survey 2000 consumers for a particular product. It will be more convenient for the firm to interview 2000 customers who come to the mall and look friendly. If a researcher wants to survey 1,000 consumers door to door in a particular locality, samples can be selected from house which is nearby. Houses where the people are responsive and friendly. These houses are easily or can be easily approached. Convenience sampling is not often recommended for research due to the possibility of sampling error and lack of representation of the population. It suffers from non-randomness criteria like any other non-random sampling technique. Now, this is quota sampling. A quota sampling in some cases is similar to stratified random sampling. In quota sampling, certain subclasses such as age, gender, income groups, and education level are used as strata. Stratified random sampling is based on the concept of randomly selecting units from the stratum. However, in case of quota sampling, researchers use non-random sampling method to gather data from one stratum until the required quota fixed by the researcher is fulfilled. A quota is generally based on the proportion of subclasses in the population. For example, a researcher wants to select a sample of 1,000 from a population of 50,000. This population contains 10,000 males and 40,000 females. The researcher wants to apply quota sampling and he assigns a quota in a sample according to population proportion. So, in a sample of 1,000 people, the researcher will select 200 males and 800 females as per the population proportion. Now, quota sampling is useful technique when the cost and time constraints are there. However, the non-random nature of this sampling method is a serious limitation. Obtaining a representative sample in quota sampling is difficult because selection largely depends on the researcher's convenience. In spite of this limitation, quota sampling is used under certain specified conditions. For example, a researcher wants to stratify the population of different scooters in the city or different scooter owners in the city. However, he finds it difficult to obtain a list of Bajaj scooter owners. In this case, through quota sampling, the researcher can conduct interviews of all the scooter owners and cast out non-Bajaj scooter owners until the quota of Bajaj scooter owner is filled. The researcher could also add other subpoints to the data set according to the requirement of the research. So this is all about quota sampling. Now coming on to the last sampling method, which is snowball sampling method. It says, suppose in this sampling, a survey respondents are selected on the basis of referral from one other survey respondents. For example, if we take a case of bullying, a person who is bullied, if we are interviewing him or her, will help us to find another person who is also bullied. This is how a referral is made. A snowball collect ice particles. It is based upon the concept that a snowball collects ice particle when it rolls on ice. Similarly, in snowball sampling, a researcher uses a respondent to collect information about another respondent. When information about the subject is not directly available, a researcher identifies a person who will be able to provide details of other respondent whose profile will fit the study. Through referral, respondents can locate other respondent easily. which could otherwise be a difficult exercise. Snowball sampling method also suffers from non-randomness of the sample selection procedure, which is one of the limitations. Now coming on to errors in sampling. There are different types of error in sampling. An error is basically defined as any differences between the average values that were obtained through a study and the true average value of the population being targeted. So there are two types: sampling error and non-sampling error. Coming on to sampling error has the origin in sampling itself. We have already discussed that only a small part of the population on a sample is taken from the study, and all the inferences are based on that particular sample. When the sample happens to be a true representative of the population, there is no problem. However, sampling error occurs when the sample is not a true representative of the population. It occurs due to some specific reasons. Sometimes sampling errors occur due to faulty selection of sample. For example, in judgment sampling, a researcher can deliberately select a sample to obtain predetermined results. Secondly, sometimes due to difficulty in selection a particular sampling unit, researchers try to substitute the sampling unit with another sampling unit which is easy to be surveyed. So these are the various conditions in which give rise to sampling error. However, it can be reduced by increasing the sample size and by stratification. This process is also discussed previously in stratified sampling. Coming on to non-sampling error, these errors are those which do not arise due to sampling. Like we can say all errors other than sampling errors can be included in this category. Non-sampling errors mainly arise at the stage of observation, ascertainment, and processing of data, and hence are present in both sampling and complete enumeration. Data obtained in complete enumeration is generally free from sampling errors. However, the data obtained from a sample survey should be treated for both sampling error and non-sampling error. Non-sampling errors occur at, at any stage of the sampling. It is difficult to prepare an exhaustive list of non-sampling error. It may be because of following reason: improper division of sampling unit of a population. It could be because of the biasness of the researcher. It could be because of the inappropriate sampling frame or some technical error.